In this lesson, we'll be looking at section 9.1, solving similar triangles. And our essential question will be, how do I solve similar triangles? Now, similar triangles are simply triangles whose corresponding sides are proportionate. So we have corresponding parts that are proportionate. So for example, we could have triangle ABC is similar to, so we're just going to use one squiggly to represent that. Triangle ABC is similar to triangle JKL. So we'd read this as triangle ABC is similar to triangle JKL. So maybe I'll put our new symbol and the words that go with it in a different color so it matches. So triangle ABC is similar to triangle JKL. And just by looking at the letters, I can set up these proportions. Remember, I'm using corresponding parts. So side AB is going to be proportionate to side JK. So what I would say is JB, or AB, is to, so AB is to JK as, and now I can set up another ratio of corresponding sides. I could say BC, and BC matches up with KL. And then my third pair of sides we could say is proportionate as well. And we could say AC is similar to or proportionate to JL, like so. So we can set up these proportions and ratios using similar triangles. So mathematically what that would look like is, say I have this triangle here. We'll call this our ABC. And we have this triangle here. Now they're similar because they would create equivalent proportions. So we'll call this one JKL. Now remember, we use the order in our statement from above, triangle ABC is similar to triangle JKL, to do our matching. ABC, AB matches up with JK. They're the first two letters. BC, the last two letters, match up with KL, the last two letters. BC to KL. And then AC, the first and last, matches up with JL, the first and last, like so. So now let's see if we can set up those ratios. So I can say AB 5 is to JK 10 as BC 4 is to LK 8. Now if we cross multiply, we'll see that 40 equals 40. And this proves that similar triangles are proportionate. So we're going to use our order of our letters to set up our proportion, and then we'll use cross multiplying to help us solve. Let's do a couple examples. Let's give it some names. And we're told triangle ABC is similar to triangle HIJ. So now I'm going to use the order of the letters. This order right here is way more important than the picture. Don't just start matching left to left, because we can spin these triangles. So we're going to use the order of the letters to help us set up our proportions. So we want to find what X is, so I need to find BC. So we're going to go BC matches up with, BC matches up with IJ. And that's going to be equal to, I got to use two different sides. So I can't use BC again, so let's use AB. AB, and AB matches up with HI. Now that we've set up our proportion, we were given this, the triangles are similar, and now we set up our proportion, now we just plug in our information and solve. So I'll have X plus 2, that's BC, IJ is over 33, and then it's equal to AB, which is 7, over HI, which is 21, like so. And now we just use our skills to solve these. I'll add my parentheses, and we'll start going through the motions. So I have 21 times X plus 2 is equal to 33 times 7. 33 times 7 is 231. Now we'll distribute. So I have 21x plus 21 times 2 is 42 equals 231. Subtract 42 from both sides. Those cancel out, and we have 21x equals 231 minus 42. It's 189. Then we'll divide both sides by 21. And we get x equals 9. Like so. So the main thing is being able to set up this proportion right here at the very beginning. That's like the really new thing right here. Can you set this up? Can we set up this proportion given this triangle similar statement? Let's try a new one. Now for this next example, we're going to look at a triangle inside of a triangle. We're given triangle ABC is similar to triangle TRC. So ABC is similar to triangle TRC. And we'll also be given some other information. So when we have something that looks like this, what I highly recommend, highly recommend, draw both triangles. Separate from each other. And it doesn't have to be perfect, it's just like a rough little sketch to kind of help us collect our thoughts. So I see the big triangle, ABC, and then I see the little triangle TRC. So I'm not drawing, it doesn't have to be perfect, I'm just drawing a rough sketch, ABC, and then I'll draw separate my triangle TRC. Just kind of helps us see everything and not get overwhelmed or confused. So what is the length of AC? Well, if I look at my main triangle from A to C, it tells me it's 10. So I have 10 down here. And then do we know the length of AB? So I look up here. Nope, that's left blank, so I'm going to leave it blank. And the length of B to C. So all the way from B to C, well, that's 7 and 5. So 7 plus 5 would be 12. I have to do the entire length of BC, so BR7 plus RC5 is 12. Now let's fill in our other triangle. So I'm just looking at TRC. So it's the TC length. T to C is our x plus 2. And then our R to C is 5. And our RT is blank. Now that we have our two triangles, it's much easier to see. We can see that the whole length of BC is 12. So this is just scratch work that helps us alleviate that confusion or stress or anything like that. So now what we'll do is we'll use our given statement from above. Triangle ABC is similar to triangle TRC. We're going to use this statement to help us build our proportion. So we have AC. So I'm going to go AC is to TC. AC is to TC. AC is to TC. So first letter, last letter is to first letter, last letter. And my next ratio, so equals, and we'll use BC. So BC is to RC. I cannot stress this enough. Do not lean on the picture too much. Lean on this similarity statement to help you write the proportion. This is always correct. These triangles spin. So use this to help us. Because once we build it, now we just plug in. Well, AC is 10. So 10 is to TC is x plus 2. And then BC is 12 is to RC is 5. And now we cross multiply and solve. I'll add my parentheses in. So now I have 12 times x plus 2 is equal to 50. Just doing my cross multiplying. Distributive property, 12x plus 24 equals 50. And now we're solving. Looks like we're going to get a weird fraction on this one. Makes sense. And that's how we can use similar triangles and proportions to help us solve these similar triangles. So thank you very much for watching this video, and I hope you have a great rest of your day.